Hello everyone, my name is Arpit from Geeksman, and in today's video we are going to discuss a question here which is flattening a linked list. Before going to what's linked list, we have to understand that a linked list is a list which is connected using pointers. And in this question, instead of using just one pointer, we have used two pointers. Here you can see we are given a linked list of size n, where every node represents a sublinked linked list itself. It contains two pointers. One is next pointer and another pointer is bottom pointer. The next pointer is pointing towards the next node, and the bottom pointer is pointing towards the linked list where it acts itself as a head node. Each of the sublinked lists is in sorted order, and our task is to flatten the linked list such that all the nodes appear in a single level while maintaining the sorted order. Note that the flattened linked list will be printed using the bottom pointer instead of the next pointer. So we have to keep that in mind while coding the question here. Let's understand better with the help of an example here. Consider this to be the linked list we are given. Here you can see that if we consider this to be our root node, then this will act as an head for this linked list, and this linked list, or I say sublinked list, is also a sorted sublinked list, and this next pointer is pointing towards this specific node. This node will also have a sublinked list here and another next which is pointing towards similar situation. As you can see, there are two main branches here. First is this main list, and the second is these sublinked lists which each main node is having, and all these linked lists are already sorted here. Therefore there is not therefore we don't have to worry about sorting them. So our task is to make this linked list in a single way. What I mean by that, I mean we have to make this linked list in this order. Instead of due to the space issue, I have written in this direction, but consider this to be in the down direction, where we have to point every down node to the next pointer until the largest element points towards null. And also keep in mind that all of their right nodes are pointing towards null also. What can we learn from here? We can learn from here we have to make the nodes right, the right node or the next node equal to null if we want to flatten our linked list. This will be our aim. So how we can achieve it? Let's go to the previous frame here. As you can see, 1 minute. Yeah. As you can see in this frame, this pointer is having this linked list sorted, and this is a similar problem. Same goes for this, same goes for this, but in this case it has only a sorted linked list, and the next pointer is pointing towards null. Now if we, instead of going to the whole problem at the same time, we divide the problem by parts. First, as you can see, this part of the list is already sorted. If now as we can see, this part is sorted. If we try to merge this function with this function using the concept of a merge sort, we can easily merge two different sorted lists together. Okay, and make a list out of it, and it will be as you can see, if we try to merge these two sorted lists together, it will form something like this. And how can we do that? We have to just create two simple separate pointers, one pointing toward here and one pointing towards here, the beginning of the lists. And as we go on, we just compare the data of these linked lists and push the elements or store the elements as in a temporary variable. First we will go towards 19 and 28, and in this two we can see 19 is smaller, so we will push the variable push the 19 node here, and then we will go towards 22 and again call the function. Now as we can see, in between 22 and 28, 22 is smaller, then we again will going to return 22 as the value. Then we will go towards 50, and as we can see, in between 50 and 28, 28 is smaller, then we are gonna push 28. Then we are going to go towards 35, and between 50 and 35, 35 is going to be the element pushed in linked list. Then 40, and similarly then 45, and ultimately after pushing 50 in the list, we will flatten this list into a simple linked list, which is this, and it in this 19 will be pointing towards null, and as you can see, if 10 is pointing towards this list, then these two lists again can be merged in a sorted order using the same concept. And for that we have to just create a merge function, which is very easy to write. Just we have to keep on going towards the element in the order, and while traversing we will just compare the values. If the value is whichever value is lesser, we will keep that value, and for the remaining list we will keep on checking that. After doing that, the element 10 and 20 will also took the place in the list. 10 will be placed up here, and 20 will be placed somewhere here. And after doing that, we will have this linked list of this whole product, and now 10 will be pointing also 10 will also be pointing towards null. Now we have just simply two linked lists, and we are going to sort these two linked lists also. And after sorting these two linked lists, or merging these two linked lists, we are going to have an answer, which is going to be this one. This one. And now instead of just rambling about the algorithm, I am going to show you code, and I will try my best to explain it from there. Now this is the code of flattening a linked list. Here first we have defined the node as data and two pointers, right and down, and then we have written the push function where we, for every new node, we push the new node. uh, if we are given a head address, then we use that address and push the node here, and the node already here will be pushed down. This is the node, you can refer it. Here we had created a new node, then in the right we have initialized the value null, and the data is what we are given, we had input here, and the already value here, the already node existing here will be put in down, and if there is no node before, then there will be value null, so in a new node down it will be null. This is for printing list, and this is the merge function which will be doing the main task. Suppose as I had already said, we are given two nodes, node A and node B. If node A is equal to null, then we are going to return B, because this is because A doesn't exist, therefore B is going to be our answer. B is going to be pushed into the sorted list. If B is equal to null, then we are going to return A, because B doesn't exist, and these are our base cases. And if for example A and B both are existing, then we are going to store that node in result. And if A is smaller, then we are going to store A node, and if B is smaller, then we are going to store B, and we are going to recursively call for the down side, means the element bigger than the element just bigger than A will be pushed downside of result by using recursively again the function merge, which will have the A down value and the B value, where we simply going to compare as shown in diagram. As shown in diagram here, 19 and 28 will be compared. If 19 is lesser, then we will compare this section with this section, or I simply said 22 node with 28 node. If 22 is lesser, then we will compare 50 with 28. If and then 35 50, 40 50, and then 45 50. As you can see, now there is no element to compare, then simply we are going to insert all the linked list left over here, and this is the process we are going to repeatedly do. As you can see in the code here, this recursive call will keep on going, and after merging the whole after merging these two data structure two linked list, we are going to do for this resultant linked list and this linked list. Then for this resultant linked list, we are going to do the same, this and this. And how we can do that? We can simply call a recursive call a recursive call using a function which is similar to merge sort function, that is going to be flatten function, where we simply are given root node. If the root node is null, then we are going to simply return it. And even if the right of the root node is null, which means the linked list is not having any right node, means the list is already flattened, we are also in that case going to return the root node. And in any other case, we are going to merge the root node here with the root right, which means we are going to merge this list with this whole segment. And how we are going to do that? As you can see in this call, we are taking just root node as an argument, and if it is null or its right node is null, then we are returning root. Elsewise, we are calling a merge function with arguments root and root right. It is going to play like this. It will initially we will give him this node, and it will see that its right exists. Therefore, it will call this node it will give this node as an argument. After that, it will give this node as an argument to the merge function here, and after this it will give this node as the argument in the merge function. And when we go there, it will find that the right node is null and the base condition is met. Therefore, it will return root. And after that, it will go here, and here the function merge will take place, and it will flatten these two linked lists in one. And after that, this merged linked list will combine with this linked list, and after that this function after combining this with this whole, a merge function will be executed, and it will simply return the answer to our main function. But before going to that and before ending the video, now I'm going to explain how we have created this data structure here, how we had implanted this example. First, we pushed 30 here, then we pushed 8 to the root, and it made the root here, and then 7, and then 5. By this, our first list is created. Then for the next part here, in the right of the root, we pushed 20, and then 10. Then to right's right, then we pushed for initially 22, then 9, first initially 50, then 22, then 19, then 45, 40, 35, and 28. This may seem a little bit out. A minute. Here, this is how we have created this structure, and with that you know how it all worked. Now all that remaining is call that flatten function and then print the list.